Hi, and welcome to the world of instrumentation and control. Are you using this equation to calculate the resistance of RTDs? If you are, then this video is for you. If you aren't, then this video is also for you. Over the years, I have met instrumentation professionals who use this equation to calculate the resistance of RTDs at any temperature. And it's not just a few of them. There are a lot of them. What's more is that there are instrumentation websites and YouTube channels who are teaching others to use this same equation. The problem is this equation is wrong. So in this video, we are going to prove that this equation is wrong and how you can correctly determine the resistance of an RTD at any temperature. First off, let's describe the equation. R sub T is the resistance of the RTD at temperature T. R sub 0 is the resistance of the RTD at 0 degrees Celsius. The alpha symbol is the temperature coefficient of the RTD you are using, and the letter T is for the temperature that we want to find the resistance for. So let's see if the equation will give us the correct resistance of a PT100-385 at a temperature of 50 degrees Celsius. Let's start with the equation, and then we substitute the values of the variables. R sub 0 is 100 ohms. Alpha is 0.00385 ohms per ohm degree Celsius, and T is 50 degrees Celsius. So the equation says that the resistance of a PT100-385 at 50 degrees Celsius is 119.25 ohms. Let's check if that is correct by using an RTD temperature versus resistance table. So according to the table, at 50 degrees Celsius, a PT100-385 will have a resistance of 119.4 ohms. But the equation says the resistance should be 119.25. Why is the answer different? The reason is because the equation is a linear equation, while the RTD is a nonlinear device. Using a linear equation for a nonlinear device will most likely give you erroneous results. Want another example? Let's use the same RTD, a PT100-385, and calculate its resistance at 250 degrees Celsius. Using the equation, we calculate that the resistance of the RTD would be 196.25 ohms. But according to the table, the resistance of a PT100-385 at 250 degrees Celsius is 194.1 ohms, not 196.25. So now it should be obvious to you that this equation will give you the wrong results. That being the case, if you are using this equation, stop using it. If you know anyone who is using this equation, tell them to stop using it. In fact, forget that this equation even exists. Okay. So we've proven that this equation is no good. What methods can we use to determine the resistance of an RTD at any temperature? The first method is to use an RTD converter app from the Google Play Store. But you have to be careful because some of those apps use this same equation to calculate the resistance, and that means it will give you the wrong results. The second and most practical method is to use an RTD, temperature versus resistance table. It's easy to use and is easy to obtain. Just make a Google search and download the table that you need. If you need tables for various types of RTDs, you can make several searches and download the table for each type of RTD. Or you can download a book that has tables for the most commonly used RTDs. There is another option that involves a different equation that will give you accurate results for any temperature. That equation, however, is a bit complex, and you have to push a lot of buttons to use it. If you want to learn the equation for accurate calculation of RTD resistances, just make a request in the comment section below, and if there's a lot of requests, I'll make a video about it. I cannot emphasize enough about the importance of making accurate measurements. If your instrument makes erroneous measurements, it can result in poorly made products, or it may even cause a fatal accident. That is the reason why I made this video, to spread the word that you should never, never, never use this equation to calculate the resistance of RTDs. I also implore you to inform other instrumentation professionals whom you know are using this equation. And that's it for this episode on how not to calculate for the resistance of RTDs. I'll see you next time in the world of instrumentation and control.